Good day to you, everyone. Today, we want to quickly run through some problem solving on independent and dependent events. In the earlier videos we sent in the classroom, we have talked about independent and dependent events. Independent events we mentioned are such that the outcome of one does not depend on the outcome of another. Right, so independent events says when the outcome of an event or one event does not affect the outcome of the second event. While dependent event talks about the outcome of one event affecting the outcome of a second event. And such events that we call dependent events involves all that which has to do with selecting items from a number um, of those kind of items where you have to not replace or where you have no need of replacing. In other words, that is without replacement. While independent events talks about the events such as those where you have to make selection and then you replace the item that was initially selected so that the sample space does not change. The sample space remains the same and the probability of selecting a particular item remains the same. We also have such events as independent events like rolling two dice, tossing two coins. Now, if we talk about tossing two coins, the outcome of a particular coin or the outcome on a particular coin does not determine the outcome on another or the second coin. If you roll two dice, then the outcome on the first die does not determine what happens on the second die. So such events are independent events. So we're going to take it. There are other examples of dependent and independent event, but we're going to take it in the line of these few examples that I have given, particularly selections that has to do with replacement and without replacement. Now, this is a very quick look at the question I gave in the class as an assignment. It said a bag contains 6 red balls, 9 blue balls, and 5 green balls. 2 balls are chosen one after the other without replacement. What is the probability that both are red? What is the probability that one is blue and the other is green? What is the probability that they are of the same color? Now, I will present one of the solution by one of the students in the class, a name withheld. So this is one of the solution a student presented in class and they were all correct. Now, probability of selecting um, two of making two selections that are red implies that the first selection is a red and the second selection is a red. So the student had written probability of red and red, meaning red first is red, second is red. So we have that as probability of the first being red times probability of the second being red. Now remember that it is without replacement. So the chances of selecting a red ball in the first case is 6/20, and the chance of selecting a second ball that is red is 5/19. Why is it 5/19? The number of red balls have been decreased by 1, and the total balls in the bag has also been decreased by 1. So the number of red balls in the second selection will no longer be 6, but to be 5 chances. And the number of balls in total will be 19 instead of 20 in the initial case. Simplifying this, we have 3/38. The second question that says find probability of selecting a blue and a green. Now, blue and green, we are not told in the question that it must be in that particular order. So if we are not told, it means that the chances or probability of selecting a blue and a green ball implies blue first, followed by green, or the or is what makes the addition sign to be here. So the or is what our addition sign becomes here, or it becomes, or it's either you have green first and blue following. So it's either blue green or green blue. So we have for blue green means blue and green. So we have 9 blue balls out of 20. Then probability of selecting the next ball to be green is 5 over 19. Why is it 5? Because there are 5 green balls in the bag and no green ball has been touched. Remember, the first selection was a blue. So the total green balls remains the same, but the total blue balls is the one that changed. Now, because one blue have been selected, therefore, we have total balls in the bag to be 19. So hence, the reason why we have 19 at the bottom here. Now, this is done with, now we are saying that or this possible selection of green first, then blue. So if it is green first, then we have 5 chances out of 20 times blue following. We have 9 blue balls out of a total of 19 now. Because we have not touched the blue ball initially in this selection now, we have not touched the blue ball initially, so the blue balls remain 19, remain 9, while the total balls becomes 19. So simplifying both brackets, you come up with the result 9 over 38 as your final answer. Probability that both are of the same color implies that you can have as both red or both blue or both green. Now, both red, that will be 6 over 20 times 5 over 19. Remember, there were 6 blue, there are 6 blue, red ball in the bag. So the second selection would have decreased by 1 for the red. So now we have 5 red to select from out of a total of 19, because the first selection has reduced the number of balls in the bag. Or it could be both blue. So if both are blue, then we have 9 over 20. Then the second selection is 8 over 19, because the total number of blue balls will decrease by 1, so you have 8. And the total balls in the bag will also decrease by 1, so you have 19. Or both could be green, 5 over 20 times 4 over 19. First selection for green gives us 5 chances out of 20. And the second selection will become 4 out of 19, because a green ball has left the bag, so we have 4 remaining out of a total of 19. Now simplifying all these, we have 61 over 190 as our final answer. So that is the solution presented by a student, and this is another solution presented by another. So I just made the two available. Now there's an example here before us. Says that Tolu goes to school on her bicycle. She has to go through 2 sets of traffic lights on her way. At the first set of lights, the probability that they will be green is 7 over 10. At the second set, the probability that they will be green is 3 over 5. What is the probability? What is that probability? Sorry, that should be D. What is the probability that both sets will be green? And what is the probability that she will have to stop once and once at a set of lights? I'm just going to allow you to see the solution to this problem. I will want to make emphasis on another example other than this one that is displaying right here. So you can come back and take a look at this particular problem, or some other time I can decide to talk about it. But since it appears in my slides, so I just decide to let it pass. Like I said, you can pause and then take a look at it fully. The solution are out there. So particularly in the problems we'll be solving right now, it will be addressing problem solving on dependent and independent events using tree diagram. Tree diagram is this kind of diagram representation that you can see right here that makes clear the um, the particular selections or particular problem that we um, have to have to address the solution. So you have some problems very easy to solve when you make use of the tree diagram. We have already talked about what dependent and independent events are. So we're going to take this example right here that says there are 10 crayons in a bag, 5 blue ones, 3 red ones, and 2 green ones. I pick one at random, then put it back and choose another. So you can see we have um, the crayons, we have blue, we have red, and we have green. I pick one at random and then put it back and choose another. So this is a selection with replacement. So we're going to draw a tree diagram because that's what we're told to do on the selection. There are two selections, so we're going to draw um, our tree diagram um, to show two selection. I also know that there are three colors here. So because there are three kinds of things in this bag, there are three kinds. In other words, there are three colors. We're going to draw three arms to represent the three colors, and then you have the first arm and the second arm and then the third arm. So each of them representing the color blue, followed by the color red and then green. Now that's the first crayon selection. That represents the first crayon selection. Now for picking the blue, we have 5/10 chances. For picking a red, we have 3/10. For picking a green, you have 2/10. Now we are saying that if the first crayon picked was a blue, then you have 5/10. If it was a red, you have 3/10. If it was a green, then you have 2/10. Now, if the first is blue, the second crayon could have been blue, red, or green. It could have been blue, red, or green, implying that I have to make another three arms, which shows possibility of the second selection after the first had been made, which is blue. So when I'm going to draw that now, okay, that's my second crayon. So my selection for the second crayon shows three arms. It's going to be this blue, it's going to be this as red, it's going to be this as green. So that's after the first was blue. But if the first was red, how many possibilities can I have in the second selection? I will also have three possibilities, so that means I'm also going to have three arms. If the first was green, so what would be how many possibilities will I have in the second selection? If the first were to be green, then I will still have three possible selections for the second crayon. Now remember that the total number of balls after selection will always remain the same when we are going to make a second selection, because this problem talks about picking and then replacing in the bag again. So for blue, we will, let's just fill the colors. All right, so if the second selection was a blue after the first being blue, then we have the second selection as 5 chances out of 10. The crayons remain 5 because when the first blue was taken, it was returned to the bag. So the total number of blue in the bag remains 5, and the total balls in the bag is 10. If the second selection was a red, remember that it doesn't matter because the second selection here for red will be 2 out of 10. And why is it going to be 10? Why be out of 10? Because the total number of balls in the bag remain the same. Why? Because the blue that was selected at first was replaced. So there will be 10 balls in the bag, and the total red is still going to be 2. It's going to be 3. Sorry, it's going to be 3. So we have 3/10. Then for the green, we're going to have 2/10. So you'll notice that all the denominators here are 10. The second selection, the denominators will also be 10 because the initial or the first selection has been replaced. So we have the same 5/10, 3/10, 2/10, 5/10, 3/10, 2/10, and that will make it for the Venn diagram on this particular problem. Now, probability, we are asked to find the probability that both crayons are green or will be green. Now, you follow the arms in the way you see them. You see this arm that has green here, and at the other end down there, you can see my cursor. We have green there, we have green here. So both of them give us green and green for first and second selection. So probably that you have the first as green and second as green, that will be 2 over 10 times 2 over 10. So what values I have placed on the arm, I just bring them together. So that gives us 4 over 100. So that gives us the answer for that particular question. What is the probability that I would choose one blue crayon and one red crayon? One blue crayon and one red crayon. Now, there is no order that was given. We are not told that it must be in that order. So, probability that one is blue and the other is green, the one is blue and the other is red, please, implies that it could be blue first, then red second, or red first, then blue second. Now, if you look at the diagram, we'll notice that we have blue, red in this. You can see my line, broken line that I've indicated, blue, red. So blue, red, that gives me 5 over 10 times 3 over 10. So of course, that will give us the probability for blue, red. Then we also have that for red, blue. So we have red, blue, you can see red, blue. So we have red, blue, that gives us 15 over 100 also. So probability that it is a blue, one is blue and the other is red, in total will be calculated as the addition of those two probabilities. So it could either be blue, red or red, blue. So for blue, red, we have 15 over 100 plus, which is or red, blue, which is 15 over 100 also. So in total, we have 30 over 100. Always reduce your probabilities to the lowest term. So the answer to that should be 3 over 10. 3 over 10 or 0.3. Now, here's another example. It says that a bag contains 4 red balls and 3 green balls. A ball is taken out at random and then put back. A second ball is taken from the bag. What is the probability that both balls are the same color? What is the probability that at least one of the ball is green? And the last question says, what's the probability that the balls are of different colors? So in this case now, particularly I want you to take note of this second question that says at least one of the balls is green. At least. When you hear the word at least, when you hear that phrase at least, it means the particular number we're talking about and above. The particular number we're talking about and above. If you have the statement that says at most, it means the particular number we're talking about and below. So at least the number and above. At least one is green. That means one green and above. One green and above. One green and above. One green and above. If it says at most one, it means one green and below. But this says at least one is green. That means the number of green you have at minimum should be one, but it can be more than one. That's why we say one and above. So let's see the solution to this problem using a Venn diagram. Let's see the solution to this problem using a Venn diagram. We have 4 red balls, we have 3 green balls. So in our Venn diagram, has been rightly placed here, you have 2 arms. The reason why we have 2 arms is because we have 2 colors of balls. So we have red arm and then we have the green arm. Now, probability of selecting a red ball in the first selection will be 4 over 7, while probability of selecting a green ball in the first selection will be 3 over 7. We are saying that it could be red. If it is red, that's 4 over 7. The first selection could be green. If it is green, then you have 3 over 7. That's for the first selection. So this represents the first selection. Now, the second ball selection, if the first was red, then the second could either be a red, that's why you have a red arm, or it could be a green, that's why you have a green arm. So that's why we have 2 arms here for red and green again. Now, if the first ball was actually green and not red, if it was green, then the second selection could also be red or it could be green. So that makes up our second selection when the first is green. So now we bring all this together. For this arm, follow the arm that way. We have red, red. So we have possible selection as red, red. Selecting 2 balls, possible selection could be red, green. So we have followed it as red, green. Possible selection of 2 balls will be green followed by red. That's green, red. Possible selection of two balls could be green, green. So that's green, green. Now we can, at the end of this, calculate the probabilities of these. So we have red, red will be 4 over 7 times 4 over 7. That's 16 over 49. Red, green, that will be red 4 over 7 times 3 over 7. That's red, green. That gives us 12 over 49. Then we have green, red. So that green, red, that's 3 over 7 times 4 over 7. That's green, red. That gives us 12 over 49. Now the last one, green, green, the same. We have 9 over 49. If you add all these probabilities together, it's going to give us 1. That means the sum of all probabilities gives us 1. Remember, we've talked about that before. Now let's see the solution to A. Solution to A, as we have here displaying, the question says find probability that both are the same color. So if both are the same color, you can see why our tree diagram is very, very helpful. If both are the same color, we just go and check for probability that have the same color. So we have green, green, we have green, green, we have red, red. So all I need to do that is either could be both color as same color will be probability that we have red, red or green, green. So that probability of red, red plus probability of green, green. Now, red, red is already calculated here as 16 over 49, and green, green is calculated here as 9 over 49. So I bring them both together by addition, and that gives us 25 over 49. So that makes it very easy. All the calculations have been done. Now, the second question that says at least one green, at least one green, meaning one green and above. So now the first selection, we have red, red. Second, we have red, green. Third, we have green, red. Fourth, we have green, green. So which of them have green of one green and above? So we have one green here, we pick it. One green here, we pick it, is a possibility. We have two greens here. Oh, both could be green. Yes, is a possibility. Remember, it says one green and above. So probability that at least one green ball is selected is probability of green, green, or green, red, or red, green. That would probability of green, green plus green, red plus red, green. Now you look at all you just need to do is to look at the results that we have calculated at the end of this our diagram and bring them all to replace these, and then you have the 3 over 49. So that makes a very easy calculation. Now you will notice that, okay, let me go back. An alternative way of solving this problem would be 1 minus probability that is red, red. Why is it that? Probability that is having at least one green, at least one green. You see that everything has if we divide these outcomes into two parts, we have no green and we have at least one green. So these three down here shows at least one green, and this one here up there, which is red, red, is showing no green. So that's why probability that it is at least one green will be the same thing as 1 minus probability that we have no green. That's probability that we have red, red. So that gives us this answer as the same. So anyone that is understood clearly can be used. Probability that we have both different colors, both as different colors, could be red, green, or green, red. Remember, we have only two colors, red and green, so it could be red, green, or green, red. So that probability of red, green plus probability of green, red. That's 12 over 49 plus 12 over 49. That will be 24 over 49. So that makes it for this particular example. I will want to stop here, and then we'll take the example 3 in the next video. We'll take the next example in the next video. I hope this has been worth listening and watching. Thank you.